सो हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर। मैं विजय कुमार सोनी आपका हार्दिक स्वागत करता हूं इन केमिस्ट्री वाला चैनल रिगार्डिंग टू योर वन एंड ओनली केमिस्ट्री। In previous video we have discussed about the just electrode potential, what is the meaning of electrode potential as the types of the electrode potential, and further we have discussed about the measurement of the electrode potential. Now the important time to discuss about the Nernst equation. What is the Nernst equation? It's just a relation between electrode potential and the concentration of the electrolyte. So the topic is your Nernst equation. This is the Nernst Nernst equation. You can say it's just a relation between electrode potential and concentration of electrolyte कि पर्टिकुलर किस प्रकार से इलेक्ट्रोड पोटेंशियल कंसंट्रेशन पे डिपेंड करता है, इस बात के लिए डिराइव किया गया. व्हाट इज दैट? फॉर दिस सपोज देयर इज फॉलोइंग reaction in a cell, that is A of A mole, B of B mole reacts with each other to give the C of C mole. This is the C of C mole plus D of D mole. So according to thermodynamics, what is that? The equation gives free energy for the cell will be your del Z is equals to del Z naught plus RT ln C's power C D's power D, means concentration of product upon concentration of a reactant, where A, B, C, D, these A, B, C and D are the just coefficient of the reactant and product. This is the equation first, where del G is equals to gives free energy, its value is minus NFE, while we can denote it just E cell also, and del G naught is your, you can say, standard, gives free energy with the value as a minus NFE naught of cell. These are the two values. Then whenever we'll keep the values of del G and del G naught over here, then equation first will be, what will be? Listen me carefully. This is the just minus NFE cell. This is minus NFE naught cell. This is the RT plus RT ln natural log C is power C, D is power D, A is power A, and B is power B. This is the B is power B. This is the equation second. If we'll take just a negative as a common from just right side, so this equation will be as follows: minus NFE. This is the NFE cell. This will be minus common, so the equation will be NFE naught of cell. This is the plus RT upon, this will be minus RT ln C is power C, D is power D, A is power A, and B is power B. This negative remains cancelled. On dividing just by NF to the entire equation, on dividing to entire equation to whole equation by NF. So it will be NF E cell upon NF. This is the NF E naught of cell upon NF. This is the minus RT upon NF. This is the ln C is power C, D is power D, A is power A, and B is power B. This was about the further. Now NF to NF remains cancelled. So the equation will be E cell is equals to, this is the E naught of cell minus, this is RT upon NF. This is the ln, or you can say natural log E base. This is the ln C is power C, D is power D, A is power A, and B is power B. This is the equation, just you can say second. Here is just natural log. If you want to change it in log 10 base, then it will be multiplied by the 2.303. So you can say E cell is equals to E naught of cell minus 2.303 RT upon NF. Now it will be log 10 base. Concentration of product and concentration of the reactant. A is power A and B is power B. This is the equation third, and it is called as just Nernst equation. This is the first form of the Nernst equation. Relation between electric potential or just EMF of the cell and concentration of the half cell. If we'll go with the further, then E cell is equals to, you can say EMF of the cell, EMF of cell, and E naught of cell is equals to standard EMF of cell, that will be E naught of cathode minus E naught of anode, which will be given as a cathode and anode. R is the gas constant with the value of 8.314 joule Kelvin inverse, mole inverse, and N is the total number of electron, while T is the temperature, standard temperature, that is the just 298 Kelvin temperature, and final is your F, Faraday constant with the value of 96500 coulomb. This was about the just E cell, E naught of cell, R, T, N, F, so on. When we'll keep the value in equation third, what will be, we'll discuss in the next slide. Go through with the entire part of the just derivation of your Nernst equation. Now, if we'll keep the value in equation third, then what is that? Listen me carefully. If we keep all the values in equation third, then this is the equation third will be this is your E cell, this is your E naught of cell as a cathode minus anode minus 2.303 into 8.314 into 298 as a temperature upon N. F is the Faraday constant 96500. This is the log 10 base, C is power C, D is power D, A is power A, and B is power B. On solution, it will be E cell is equals to just your E naught of cell. This will be minus 0.0591 upon N log 10 base, C is power C, D is power D, A is power A, and B is power B. This is the another form of Nernst equation as a equation number 4, which will be used for the numerical. So this is the another form of Nernst equation. This is the Nernst equation. So this was about the just two important equations as a Nernst equation. E cell is equals to E naught of cell minus 2.303 RT upon NF log 10 base, C is power C, D is power D, A is power A, and B is power B. While the another is your E cell is equals to E naught of cell. This will be on solution of these values R, T, and just F, where R is equals to 8.314, T is 298 Kelvin temperature, and F is the Faraday constant. Then the value will be as follows. We can write it in another form also. This is the E cell, this is the E naught of cell, this is minus 0.0591 upon N log 10 base. This is the product, so we can say the concentration of product upon concentration of reactant. So you can write it as follows also. This is the equation number 5th as a Nernst equation. These are the three important form of the Nernst equation. So this was about the derivation of the Nernst equation. Go through with the entire matter. Now we'll go with the just applications of the Nernst equation. That is very important. So if we'll go with the further, then first of all we'll go with the applications of the Nernst equation. What are the important applications of the Nernst equation? Let's see. What are they? There are just you can say 3 to 4 applications regarding to the applications of the Nernst equation. So see the entire matter properly, because of without doing the practice of Nernst equation, it is not possible to do the questions as a numerical. So this is the applications of Nernst equation. Applications of Nernst equation. If we'll go with the applications of the Nernst equation, then first application will be to know, to calculate EMF of galvanic cell. This is the galvanic cell, or you can say Daniel cell also. Number 2, to calculate just electrode पोटेंशियल, पर्टिकुलर कोई भी हाफ सेल देकर के आपसे इलेक्ट्रॉन पोटेंशियल कैलकुलेट करना चाहे तो भी कैलकुलेट कर सकते हैं. थर्ड, टू कैलकुलेट जस्ट इक्विलिब्रियम कांस्टेंट, पर्टिकुलर इक्विलिब्रियम कांस्टेंट कैलकुलेट करने में. एंड जस्ट फाइनल, टू कैलकुलेट गिव्स free energy. These are the four parts of the just applications of the Nernst equation. First of all, I would like to go with the just to calculate the EMF of galvanic cell. This is the first part. To calculate EMF of galvanic cell. If we go with the just galvanic cell, then it acts this following reaction, that is the Zn plus Cu plus 2 changes in Zn plus 2, and this is the Cu reduces for the galvanic cell. So we can say Nernst equation, what is that? That is E cell is equals to E naught of cell minus 2.303 RT upon NF. This is the log 10 base. Concentration of product. This is the C is power C, D is power D, and A is power A, and B is power B. This is the Nernst equation number 1. If we'll keep the value in equation first from the reaction, so we can say from the reaction, this is your E cell is equals to E naught of cell minus 2.303 RT upon 2F. Why here is the 2F? Because of whenever Zn changes in Zn plus 2, then it will be loss of 2 electrons, and whenever Cu plus 2 changes in Cu, then it will be gain of 2 electrons. So here is the N is the total number of electrons, as we have discussed in your Nernst equation, and here is your log 10 base. Concentration of product is as a Zn plus 2. This is the Cu upon, this is the Zn, concentration of reactant, and this is the Cu plus 2. This is the Nernst equation regarding to your galvanic cell. If you solve it, then the value will be E cell is equals to, this is the E naught of cell minus 2.303 8.314. So before taking, if you will go with the just solid substance, तो solid substance के लिए यहाँ value आपके पास में Zn and value of the Cu will be as a 1 unity, जो कि आपके पास में neutral substance है. So the equation will be, what will be? This is the E cell is equals to E naught of cell minus 2.303 RT upon 2F, and this is the log 10 base. This is your Zn plus 2 as the anode, and this is the Cu plus 2 as a concentration of cathode, as a concentration of electrolyte. This is the second equation, and this is the Nernst equation for galvanic cell. This is Nernst equation for the galvanic cell. If we'll keep the value, then E naught of cell will be your E naught of cathode. As a cathode, it will be Cu plus 2 oblique Cu minus E naught of Zn, just anode, as a Zn plus 2 oblique Zn. And this is your, you can say, yeah, just it's your E naught of cell, EMF of the cell, standard EMF of cell, EMF of cell. Now I would like to go with the just further. R is the gas constant. This is the gas constant. Then its value is 8.314 joule Kelvin inverse mole inverse. And if you go with the T temperature, that is your 298 Kelvin temperature, and F is the Faraday constant, Faraday's constant, with the value of 96500 Coulomb. So its another form will be as a, you can say, E cell is equals to, this is E naught of cell, where we can keep the value as a E naught of cathode minus anode, and minus 0.0591 upon n. As a n we can take just 2 electrons, and this will be your log 10 base. This is the Zn plus 2, this is the Zn plus 2, and upon Cu plus 2, anode upon cathode. This is the another form of the Nernst equation for the numerical. Nernst equation as a EMF of the galvanic cell. Nernst equation for EMF of galvanic cell. If we want to calculate, then it's too easy because of the concentration of solution is 1m and 1m, क्योंकि हम पढ़ चुके गैल्वेनिक सेल में ZnSO4 की कंसंट्रेशन 1, CuSO4 की कंसंट्रेशन आपके पास में 1, और यहाँ आपके पास में वैल्यू गिवन है, एंड व्हाट इज दैट, ये वाली वैल्यू आपके पास में होगा कुछ इस टाइप से. कॉपर के लिए आपने करना है, दिस इज द 0.34 and this is the minus 0.76 volt, so it will be 1.10 volt. तो ये वाली वैल्यू यहाँ पुट कर दें. This is the equation through which you can solve any kind of the numerical. If we keep the value, then E cell we can say, or E cell is equals to, this is the 1.10, this is minus 0.0591 upon 2, this is the log 10 base. Concentration of Zn solution is 1, and this is also 1. Log 10 base 1, 1 by 1 it will be just 1, and log 10 base 1 will be as a 0, so entire part will be 0, so we can say E cell is equals to 1.10 volt. So this was about the EMF of the galvanic cell. EMF of galvanic cell, ये था आपके पास में पर्टिकुलर वैल्यू, एंड दीज आर द टू इक्वेशन रिगार्डिंग टू just calculation of EMF of the galvanic cell as a for numerical, and this is for the just general way of the Nernst equation for the galvanic cell. This was about the first application. Take it seriously because of there will be a lot of question regarding to Nernst equation. Now it's time to discuss about the second application to calculate the electrode potential. It's very important application also because it will be a lot of question, as I told you, in your NCRT, not only in NCRT but also in your competition exam. So this is your second application to calculate the electrode potential. So we'll erase the matter of the first application. Now we'll go with the just your second application, that is the calculation of calculation of calculation of electrode potential of electrode potential. And as we all know, here we'll use of reduction electrode potential because of we can't take the negative value of the EMF of the cell. That's why it will use of reduction electrode potential. So for this we'll take just one of the reaction, M plus N by the gain of an electron changes in M. For this, just we have discussed, Nernst equation is your, you can say, E cell is equals to E naught of cell minus 2.303 RT upon NF. This is the log 10 base concentration of product upon concentration of reactant, A is power A and B is power B. By using this equation for the reaction, so the equation for the reaction will, इस इक्वेशन में कन्वर्ट करें तो आपके पास में होगा, this is the E M plus N oblique M is equals to E naught of M plus N oblique M minus 2.303, this is the RT upon NF. This is the log 10 base concentration of product upon concentration of reactant. So this is the M and this is the M plus N. As we know that the neutral substance exists the unit value. So this equation will be E M plus N, this is the M plus N oblique M is equals to E naught of M plus N oblique M minus, this is the 2.303 RT upon NF, this is the log 10 base 1 upon M plus N. This is the first form of just your galvanic cell to calculate electrode potential. Just electrode potential, to calculate the just electrode potential for a cell. If we keep the values of all the constant, then this may as follows: E is equal to M plus N oblique M. This is equals to E naught of M plus N oblique M minus 2.303. This is the 8.314. This is the 298 Kelvin. This is the N into 96500. This is the log 10 base 1 upon M plus N. If we'll solve the value, then it will be E M plus N oblique M. E naught of M plus N oblique M minus 0.0591 upon N, and this is the log 10 base 1 upon M plus N. This is the another form of the Nernst equation to calculate electrode potential. Just electrode potential, where in the question value of E naught of m plus n will be given, and the n also, and the concentration of the electrode potential, just electrode also. So this was about the second application of the, just you can say, Nernst equation. So, dear doctors and engineers and chemistry lovers, will meet in the next video with the just rest of the two important topics, as a in the calculation of the equilibrium constant and in the calculation of the Gibbs free energy. यूं ही अपना प्यार, यूं ही सपोर्ट अपना मुझे देते रहिए। नो डाउट मैं हर बार आपके लिए एक नया टॉपिक के साथ में एक वीडियो लेकर के आता रहूंगा, और यूं ही हम पर्टिकुलर एनसीईआरटी जैसे सिलेबस कंप्लीट होता है तो चैप्टर वाइज इन टेक्स्ट और एनसीईआरटी क्वेश्चन भी सॉल्व करेंगे, एंड विल टेक अ लॉट ऑफ सीबीएसई क्वेश्चन एंड आरबीएसई क्वेश्चन पेपर ऑल्सो। हर एक क्वेश्चन पेपर का सोल्यूशन भी मिलेगा, हर एक चैप्टर का एनसीईआरटी और इन टेक्स्ट क्वेश्चन का भी सोल्यूशन मिलेगा। इसी प्रकार से फिर मुलाकात होगी आपसे एक नेक्स्ट वीडियो में नए टॉपिक के साथ में। तब तक के लिए शुक्रिया, धन्यवाद।